All right, and we are live. Okay, we're just going to post these. Give people a minute to hop on. Oh. All right. Good morning, Ravit. I see you on there. Hello. Okay, so we do have people hopping on, and so we can start. Welcome to the Cool Data Project Show. I'm Kristen Kerrer, a developer advocate for Comet, where with one function you can make ML runs reproducible. And the Cool Data Project Show is where I interview practitioners in ML, DL, AI about projects they're working on, their approach, and methodology. So super excited to have Dickson with us today, who is going to talk about running models on CPU instead of GPU and about some computer vision projects that he's worked on. Dickson, would you like to introduce yourself?
Yep, sure. Hey, hello everybody. So my name is Dickson and I'm from Kuala Lumpur here in Malaysia. And right now, before this, I was a academic. I was teaching in a local college here in Malaysia. And only recently I've joined ZenML as a developer advocate. So during my time as a academic in the field, I taught electronics, I taught microprocessor and programming subjects. And I've also got into organizing a couple of robotics workshop for teenage students who's trying to get into robotics. And during my time as an academic as well, I got a lot of training and exposure in academic research, and I've published in a few academic journals as well, reputable ones like Nature, Elsevier, IEEE Transactions, and I love open source, so that's what I do in my free time, and I contribute to an open source computer vision library known as Ice Vision. So if you're free, go check them out. Yep.
All right, awesome. So let's hop into a demo of what we're going to be looking at today.
Cool.
This is super. I got so excited when I saw this on LinkedIn for the first time. Okay, so here's Dickson's computer vision model to detect pistols. And we have another one, right? We're also going to talk about looking at these detecting license plates.
I should probably put in soundtrack next time. Huh?
Right? Everyone likes music.
Yep. Thank you. Thank you for showing this demo.
Yeah. Okay. So what was your motivation for these projects?
Well, this, as you've seen just now in the demo, on the surface, this project just looks like every other computer vision object detection project. It runs and it draws like a box around certain kinds of objects, and it's cool. But what's even cooler is that, and it's my prime motivation of the project, is these models, they run on CPUs instead of GPUs. And traditionally, if you're in computer vision or AI and deep learning, especially, you might understand that this model, they don't traditionally run on CPUs, and they do well. It's like super duper slow.
Yep.
And the motivation of this project is that what if we can put this traditionally heavy algorithms or model and put it onto like a CPU? So what this means is that if right now you have a CPU Core i5 4-core CPU at home, you can readily run this model. I think that's the exciting part of this, which means that you don't have to fork out like cash, a lot of money to get like expensive GPUs anymore. You can run on any commodity CPUs that you have maybe lying at home. That is the motivation.
Yeah, that's really cool because I was wondering if it was, when you said a CPU, if it was a farm, but it sounds like you can just take your computer and go. That's awesome.
Yep.
So we have Frank here asking about the frames per second. Are you able to talk about the frames per second in those videos?
Uh, Frames per second viewed, or there are 100 frames. Oh, it's frames per second. So, which means in 1 second it processes like that amount of frames or images. So that's super fast, especially if you know that running on CPU, this is like a mind-blowing number. I don't think I've seen this kind of numbers on CPUs. GPUs probably, but traditionally this isn't very possible on CPUs until very recently.
Okay, and can we talk a little bit about, how did you collect the data for the pistol demo?
So the pistol demo, the data was collected. I didn't collect the data actually. It was from a site called RoboFlow. I think
Mhm.
on that site, people actually can collect data and make their data available to everyone. So I kind of stumbled upon a data set where someone actually labeled like pistols and firearms, and they make it available on the data on RoboFlow. And I downloaded that data set and tried to run it, and surprisingly, it works well. And the model that I was using was a YOLO V5 model.
Mhm.
Yep. And for the other example, which is the license plate one, well, this one's more interesting because I start from scratch with this one, because we're in Malaysia, right? And nobody in Malaysia tries to collect license plate and upload upload it on a available platform out there. So I had to like walk around my neighborhood to take pictures of cars and the license plate and painstakingly manually label all of them one by one. I think I had like close to 100 images or something like that. Yep.
That's awesome. That's the type of stuff I like to hear. For my computer vision model where the bus goes by my house, I literally took video of the bus going by my house and then used a little script to turn that into images and manually did it myself. So did you find that you were able to go out and take those pictures, and in that one set of going out and taking pictures, that was enough, or were there additional things that came up along the way and you had to go take more pictures, or was it like smooth sailing?
No, it's far from smooth sailing. The first time I went, the first time I went out, the weather was sunny, super sunny. So I took very bright pictures. And
Mm-hmm.
then I started training my model. And then when I tested it, and I found out that, well, these pictures are super bright, and the pictures that I'm testing on, they're not exactly sunny. No, they are like cloudy or even maybe maybe rainy weather. So because of that, then I have to like wait until the weather is not so sunny and go for another trip, so that just to make sure that the data set is well balanced with a few weather conditions, with a few lightings. I went out in the morning, and sometimes I just went out like at evening, just before sunset, to make sure I have a balance of both bright and not so bright and dark pictures in the data set. Yep.
Oh, that's great. I love that. And so you didn't have that issue with the pistol data set. They had all sorts of different orientations and
Well, I'd say the pistol data set was kind of like a shortcut for me.
yeah.
Well, yeah, traditionally, I'm not sure if that data set is even enough for a real world, use case. And that one, it's just for me to toy around, just as a proof of concept to show that this we have this data set that you can train this model on this data set and can run on the CPU. And you can just swap that data set out with any data set that you want. You might want to detect bus, you can just put in a bus data set or a cars data set or license plate, or whatever you wish.
Mhm.
So yeah, but I'd say the fun part is where most people think it's painful, which is the data collecting and labeling. I feel like that was the part that I learned the most about building the models, because that's where I learned that, this is how I should collect my data. I should make it balance between bright images and dark images. I should make sure that the angles, they are not varied and there's not only in one direction. So I'd say that most of the learning happens over there. And yes, even though it's painful to draw bounding boxes one by one onto each images, but I'd do it again.
Yeah. And what software did you use to draw the bounding boxes?
From I use the open source CVAT software. I'm not sure if you heard about it, by
Mhm.
Intel. So there are a bunch of other easier to use software, I think, but this is the one that I'm familiar with, CVAT, and the other one is Label IMG. They're both open source.
Label IMG is the one that I use too.
Yeah, I love that.
Okay. And so are there other things that you can tell us about your methodology?
Well, methodology. So the methodology that I use, well, I came from an academic background, and my thinking in the beginning was kind of naive. So my methodology, at first I thought is I'll just collect the data and then I'll train the model on that data and then I'll just run an inference after the model is trained. So that was what the methodology that I have in mind. But in reality, this is not like that. Usually it goes forward, and then when you get at the end, you go back to collecting data, or you go back training the model because you figured out that, oh, it's not good enough. Oh, the data set is incomplete. Oh, there's bias. There's problem with the model here and there. So uh, in real world, it goes from data collection, training, and inference, and then it goes back again, and you go like a couple rounds over there, couple iterations until you feel that your model is performing at a good enough accuracy. And
It
that's
is.
how
It's
I
so iterative.
Yep,
Um,
iterative process.
okay. And Andre is asking about whether you're training and scoring on the CPUs.
Uh, Uh, yes, that's a good question. Thank you, Andre. Yep, I should highlight over here that the CPU is only during the inference part. So the training side, I still use like a GPU that I luckily have in my local machine. Or if you don't have a GPU, you can always use a free service like a Google Colab or something to get the training done. Because at this
Mhm.
point of time, it's still not so easy to train deep learning models on a CPU. Is not still very fast, although there are research breakthroughs already, but it's not like very available yet at the moment. So I did use GPU for the training and inferencing on the CPU.
Now, so are we at a place where there's like a real benefit to companies where you still have to train on a GPU, but you can run on a CPU? I guess, right? You'd be able to pay for GPU usage on AWS or something, but you just then don't have to pay for that when you're running. And so you save some money there. Are there other benefits, or is that the main benefit?
Yep, exactly. I think you nailed it, because training doesn't happen so much
Mhm.
as inferencing. Like if you put a model into a production, you're running it like 24/7 in most cases, right? So if yet that model has to run on a GPU, so you'd be paying for that GPU 24/7. But if you can run that model on a CPU, you'll be paying a lot lesser on running that model. And occasionally, when you want to update that model, let's say you have some new training data coming in, or you think that the model needs some updating because the model isn't performing well anymore, then you can just go on rent a GPU instance, train it, and then just get that model out and put it on a CPU again. So the cost savings is still over there.
Okay, and so you had mentioned that you were using YOLO V5 for one of the models. Are both of the models YOLO V5?
For the pistol model, I use YOLO V5, YOLO V5 model, and the other one for the license plate one, it's actually YOLO X.
Oh, okay. What are the differences? What's the difference between the two models?
Well, they are very similar in many ways, except YOLO V5, I think, it came out first,
Okay.
and then YOLO X came up, but that's not the end of it. The creators of YOLO V5, they keep updating their repository even after YOLO X has stopped, pushing out updates. So architecturally, I think they are similar, but I've seen a lot more activities in the YOLO V5 because they keep updating the repository with newer and newer models. And on the performance side, I think they are equal, or maybe I think right now YOLO V5 is slightly better because of the frequent updates.
Mm-hmm.
Yep.
For me, I used YOLO V5 just because it's so available in the libraries that I found, and it just seems to be more prevalent in blogs, that it just felt more accessible and easy.
Exactly. Are there questions? I saw something came up just now.
Andre said using a linear transformation to simulate changes in contrast and brightness in OpenCV.
Yep.
I've seen that availability. I haven't actually done it yet myself. Did you do any sort of transformations of your images, or just went with the images themselves?
Yes, I did. Like on top of the images that we collected by hand, we also did some augmentation on the brightness, on the contrast, on the color, and so on and so forth, just to make sure that the data set is diverse enough and it would run well on the real world image. So yeah, we did that.
Now, did you run the model on the regular images before doing the augmentation and see a performance increase, or did you just augment the images from the beginning?
Yeah, I did augment the images from the beginning because
Mm-hmm.
I collected, I think, like maybe 100 images, and I recall that I don't get a very good performance out of that 100 because, relatively speaking, 100 images, they are not a lot of images for a deep learning model, and some people will be surprised. What? Only 100 images? It's like sometimes impossible to get something running with 100. Of course, it all depends on the nature of the problem. Some problems are harder, you need more images, and some you need lesser. Yeah, but with this problem of license plate detection, I couldn't get like a good result. A lot of false detection just using the
Yeah,
yeah just 100 images. So I had to find a way to enrich that data set by doing this augmentations and applying various transforms.
yeah, I'll have to try that too. But yeah,
Yeah.
100 certainly feels like a lot when you're when you're drawing your own bounding boxes. But yeah, not a lot. So, were there any other gotchas along the way? Any other things that caught you that you'd like to share?
Yep. So one of the things that I touched on just now was the data collection, and yeah, one gotcha was I thought in the beginning I was very ambitious. I thought, oh, this license plate or this pistol problem looks like an easy problem, and I can probably get away with maybe 30, 40, 50 images, but not so. Not I didn't get a good enough result with 30, 40 images with the YOLO V5 and YOLO X. Um, but interestingly, when I switch that to another library, I'm using Ice Vision, which I am one of the core developers. I can sometimes get away with it. So I think it is also like down to the library that you use, the model that you use to train it. So it really depends on the nature of the problem, how hard the problem it is, how many images you've got, and what are the libraries that you're using. And yep, I wish I knew this earlier. Yep. And other than that, is the CPU thing. So how did I got into this CPU thing was let me share a story on how I got here. So when I was an academic, I had a chance to collaborate with a company that runs the toll booth in Malaysia. So they have like massive scale. And one day we were collaborating on this project, and they came presenting to us saying that they need a model to detect license plate. So as an academic, I was super enthusiastic because I thought, oh, this is something doable, and this something easy to do. With computer vision, we have so many state of the art models already out there, and so I kind of engage with them, and I start training my models on the GPUs and expecting that my models will be run on a GPU as well. But midway through the project, that's how I discovered that, oh, actually they don't have a GPU to run the models on what they only have is a CPU or maybe a couple of CPUs to run the models on. So yeah, we were shocked, and nobody was expecting this CPU thing to come into the picture. Yeah, and this is the lesson that I learned, that in any model or in any problems you're trying to solve, make sure you look at what's the end. Like, it's not just about the models, but it's where are you going to run the model. So what infrastructure you have to house that model, that is perhaps worth looking into, especially in the beginning, because you might be training like super duper complicated model with fancy results, right? But at the end, it doesn't run because it's too heavy to be run on a CPU, and that model just becomes useless. And that was what happened to me. We trained like a fancy model in the beginning, like a transformer based model with very good results on paper, but it doesn't run because it's too heavy to be put on the CPU. And at the end of the day, what we used was a humble MobileNet V2, which is an ancient computer vision model, but it runs on a CPU and it does the job well. So lesson is like, don't don't be too focused on using the latest and the greatest model. It As academics, we tend to do that, but in the industry, I realized that it doesn't have to be the latest and greatest. As long as it does the job well enough and it runs, then I think that's good. Yeah, that's some of the gotchas that I
Yeah,
encountered.
yeah. No, definitely in industry infrastructure, it can't be assumed.
Yeah.
And so Anders is now wondering if you ever tested it on a Raspberry Pi.
Oh wow, that is a super interesting topic. I'm a big fan of Raspberry Pi as well, but I haven't tested this model on a Raspberry Pi. And I know it's possible, it's doable. I've seen people do it on a Raspberry Pi, but I haven't tried myself on a Raspberry Pi. So if you have any results on Raspberry Pi, please share it with me.
Okay, and one of my favorite questions, would you say you're good at keeping up with best practices? Where do you think you could improve?
Oh wow. Um, I think if you're in machine learning or deep learning for some time right now, I think you would begin to notice that it's getting overwhelming to stay in this field. Breakthroughs, major breakthroughs are happening, like it used to be yearly, and then it becomes monthly and sometimes weekly basis. Like new discoveries are being made now and then, and it's getting really hard to understand, and it's getting really hard to keep up as well. And for me, I try my best to keep up, but I know that I don't know everything there is right now. So I'm also trying to get myself involved in learning new stuff, taking new courses, join community meetups, trying to exchange things on the latest technology out there. Yep, and I think it applies to everyone too. It's really so many things to look into, and it's really an exciting time to be alive and to be doing deep learning right now.
Do you have a favorite meetup or any favorite resources that you use for continuing education that you can share?
Well, for me, I'm a very big fan of open source library. So with deep learning or computer vision related ones, my go-to are fast AI courses. I'm not sure if you've heard about fast AI courses, but it's a course aiming at bringing computer vision or deep learning to non-experts in the field. Yeah,
Mhm.
and they have like a huge community over there. And the interesting part is that you'd find a lot of people coming from other fields. Like someone might be a teacher, someone might be a ballroom dancer, someone might be, I don't know, from
Yeah.
other fields jumping into deep learning. And not only are they there, but they're doing really well, and they're winning Kaggle competitions,
Oh, okay.
doing really well, and they're not even like a expert in the field. So my go-to resource are definitely fast AI, and I also really like the way they teach the course, because with fast AI, the teaching philosophy, I think, is a little bit different than the conventional way of teaching deep learning. The conventional way is to go to the bottom-up approach, in the sense that you need to learn math, and you need to learn what's a matrix. You need to learn a lot of the smaller components before you get to do any of the deep learning stuff. But in the fast AI, it's flipped. It's the other way around. So the moment you start the course, you get to run your code, and you get to train the state-of-the-art model already right from lesson one. And I think this is like for newcomers especially, this is very encouraging, because they don't have to wait long until they see anything running. And yeah, and those models are not just random models, they are models that can win you Kaggle competitions. Yeah.
That's crazy. I was on Kaggle yesterday, and they just launched a new competition like 3 days ago that's for horse racing. But it's actually, they're giving you the latitude and longitude as the horses go around the track. And they want like insight into the best path to take. And I was reading this, and at first I was like, oh yeah, this looks really cool. And then I continued reading, and I was like, whoa, this actually is not for me. Right? I was excited for a second, and then I really read what they were looking for, and I was like, whoa. So would you say that this is the final state of these two projects? Are you continuing to work on them? Is there some place you're looking to get, or would you say that these are finished?
No, this is far from finished. So this is actually just the beginning, and it's probably just a proof of concept stage, I would say, right now. So it's just showing that the model is good enough to detect certain objects in an image. And this is something I discovered recently, and I realized that putting a model from a proof of concept stage and putting it into like a real production stage is not very straightforward, actually. And I think by now, I think we're all familiar with the Gartner survey. I'm not sure if you heard about it. Like
Oh, yeah.
it says, yep, majority of machine learning models don't make it into production. I think the number is like 80 something percent or something. So 87% of machine learning model don't actually end up in production or failing at some stages. So yeah, this is the wake up call that have me thinking deeply on whether or not this model is ready for production. I think it's far from production ready, and putting a model into production is also not just about training and evaluating, just like what we did over there. And it's more about the engineering side of things, like where do you house the model, and how do you account for the latency. Does the model have biases? And all these are, I think, factors that we all need to consider when putting a model into production. So this model is nowhere near production, is nowhere near final. Yeah, but it's an interesting thing to see right now.
Yeah, no, and I think for myself, a lot of my models didn't make it into production because of infrastructure. And I wonder, if a couple years ago when we were having these issues, if we would have been able to run them on CPUs, would it have been different, or more enticing at least? Because before you had like the cost and building out the data infrastructure as well to make sure everything's streaming.
Right.
So if people wanted to be able to follow your work, where would they go?
I'm on LinkedIn and most of the time, and occasionally I go on to Twitter as well. Yep, you can find me there on my social, and of course on my website as well.
All right, awesome. And so is there anything else you want to share before we finish up the show?
Well, I'm not sure if your audience are like trying to start with deep learning or machine learning. This is something that I wish I knew earlier when I was starting out with deep learning. So there are like a few myths that I would like to like clarify, because with deep learning, a lot of people think that you need a lot of math to get started in deep learning, but the thing is, with good libraries, like you don't need a lot of math. Just maybe high school math is sufficient. So if you're trying to break into deep learning, don't let this be something that stop you. And the other thing is, you might think that you need a lot of data, but some deep learning models you can get record-breaking results even with less than 50 items of data, less than 50 images maybe, yeah, in some. So it may not be the case that you need like thousands of data points for deep learning models, because like we all have this impression. And lastly, one of the myths that I wish I knew earlier was we need a lot of expensive computers to train deep learning and to run deep learning. So right now, I think we know that's no longer the case. There's a lot of free tools, open source tools out there. You have Google Colab that gives you free GPUs to train models. And right now, you have tools like what we show today that allows you to run models on the CPU. And they're all open source, they're all for free, and it's really exciting time to be doing deep learning right now.
Yeah, so context based.
Yep.
So with 50 images, once you go through augmentation, how many images actually end up being in the sample?
I don't know. It depends on how
used for the license play model.
I forgot the exact numbers, but I remember it's something like 1 to 3 augmentations or something, which means one image it turns it into 3 different variations or something. You can of course set it to be how aggressive you want to augment it. You can augment it to 10 images if you like.
Okay.
Yeah, it's a variable that you can tune.
Okay, awesome. Well, thank you so much, Dickson, for sharing your models with us and chatting through how you did this. This was super fun.
Thank you for having me.
All right, awesome. Have a great day, everyone. Thank you for joining us.
Bye-bye.
Bye.